नमस्ते। और आज हम देसी न्यूज़ नेटवर्क पे हैं। आज हम थोड़ी सी टॉपिक्स डिस्कस करनी है केमिस्ट्री के पास और एक और चीज़। लेकिन आप सबको मुसलमान के दोस्तों रमज़ान मुबारक आपसे कहना है। क्या अंग्रेजी में बात करनी है? Welcome to the Desi Network. I'm your host Rajesh Kutrapalali Ravinder Singh. Sorry, it's a bit long, but our top stories for today. The curious case of one man known as Rakesh Kutrapali. Kutrapali has been missing recently from a school known as CB, also known as Chinese Bai Secondary School, and the authorities have been lookout as the school has issued a search warrant looking for him. We will be having an interview with his French teacher known as Madame Laflèche. Yes, Madame Laflèche. And Laflèche will explain to us how he has not showed up to her French class for the past couple of months. If you're watching this, Rakesh, please go back to school, as school is good. But now we're going to do another top story for today. It's going to be talking about the prestigious program for a select few students known as the International Baccalaureate program. It is an intensive program, and in order to get into it here in the local Desi studio headquarters of Ottawa, Canada, you need to take this test known as the the CAT test. And the CAT test, you have to go to the school, write it, and everything usually goes to plan if you're smart enough and if you're brown. But we in our previous segment we talked to another boy known as Krishna, and we were talking about when we documented him studying for the exam and going to take the exam. Now we will be going back to his house to check his results for the exam. So now we'll be going to Krishna. Let's go. Hello, hello Destiny's Network. So I know you've been following me on my journey. I've been studying really hard. So I have the letter here. So I'm just really hoping that I get into this program that I studied really hard for. I took the CAT test, and I think I did really well. So let's open the letter. My son got in, but hopefully your dad doesn't beat you up too hard with the chappal tonight. So we actually analyzed his mark scheme of his test, and it said that he actually screwed up on the stoichiometric part of his test, which is actually categorized as chemistry in the International Baccalaureate program. So we're going to be talking about this controversial topic, which has been perplexing many in the IB and everywhere around the curriculum, as it's been taught everywhere in grade 11 and 12. So the word stoichiometry derives from two Greek words known as stoichion and metron. Stoichion meaning element and metron meaning measure. So stoichiometry deals with calculations about masses, sometimes volumes, but not really, of reactants, products involved in a big chemical reaction. It is a very mathematical part of chemistry, and be prepared to use a lot of calculators for it. It is used by, it was created by, I think, Mr. Singh in India back in long time. Actually, it is actually created by Jeremiah Benjamin Richards, I'm being told right now, as he was the first to lay down the chemistrial principles of stoichiometry to the whole world. His name, if you didn't catch it, Jeremiah Benjamin Richards. So stoichiometry actually describes the relationships between the amount of reactants, products during chemical reactions. As is known that matter is conserved during chemical change, stoichiometry is a form of, you could say, bookkeeping at the atomic level. As through the law of conservation of mass, we know that mass doesn't change. So it enables chemists to determine what amounts of substances that they should react together, and enables it to predict how much product to be obtained. The application of stoichiometry closes the gap between what is happening on the atomic scale and what can be measured between particles and everything, the whole jazz. So now we'll be going to our correspondent, actually my son, known as Bobby Sheikh. So, hey guys, as you all know from my dad that I just previously stated, my name is Bobby Sheikh. Yes, I do not have an accent like my dad yet, don't you worry. But for that quick word right there, but really the concept of stoichiometry is crucial for the chemists in our world today. In order to do stoichiometry, you need to understand how to balance equations, and if you don't, you'll end up like poor Krishna right there. Sorry, bro. The English language is based on an alphabet of just 26 letters, but as we know, combining these in different ways leads to an almost infinite number of words and then sentences, paragraphs, books, and so on. So it is similar to the situation in chemistry where the letters are the single substances known as chemical elements. The formation of compounds from elements is an example of chemical change and can be represented by a chemical equation. A chemical equation is representation using chemical symbols of the simplest ratios of atoms or elements or in compounds undergoing chemical change. The left-hand side shows the reactants and the right-hand side shows the products. As atoms are neither created nor destroyed during a chemical reaction, the total number of atoms on each element must be the same on both sides of the equation. This is known as balancing the equation and uses a number called stoichiometric coefficients to denote the numbers of units of each term in the equation. If the coefficient is 1, there is no need to write it down. A chemical equation can be used to assess the particular efficiency of a reaction in a particular product. This can be known as atom economy, and it's a concept used for this purpose. Atom economy is an indication of how much of reactants end up in the required products rather than in waste products. A higher atom economy indicates a more efficient and less wasteful process. The concept is increasingly used in developments in green and sustainable chemistry. So thank you, Bobby, for that. It was inspirational. I'm really proud of you, my son, Kutta. So a problem in studying chemical change is that atoms are too small to measure individually. For example, even a relatively large atom like gold, which has a mass of 3.27 times 10 to the power of 25, it's not a very useful figure when you come to weigh it in a laboratory. So, but it's not really a problem because all we need to do is weigh the approximately large number of atoms to give a mass that will be used quantity in grams. And in any case, atoms do not react individually but in large numbers. So this approach makes sense. So how many atoms shall we lump together in our basic unit of amount? To answer this perplexing question, let's consider that atoms of different elements have different masses because they contain different numbers of particles, mostly nucleons in their nucleus. This means that we compare their masses with each other in relative terms. For example, an atom of oxygen has a mass of approximately 16 times greater than an atom of hydrogen, and an atom of sulfur has about twice the mass of oxygen. Now the good news is that these ratios will stay the same when we increase the number of atoms so long as we ensure we have the same number of each type. The number that accurately states this is known as 6.02 times 10 to the power of 23 and is known as Avogadro's number. And it is the basis of unit amount in chemistry known as the mole. The mole is an absolutely crucial concept in understanding stoichiometric relationships. In other words, a mole is a substance that contains Avogadro's number, which is the number of particles. Mole, the unit of amount, is one of the base units in the SI system and has a unit symbol of MOL. So mole is simply a word that represents a number, just as a couple is a word for 2, 12 is a word for dozen, and a score is a word for 20. A mole is a very large number, bigger than you can even imagine to count. But nonetheless, it is a fixed number. So a mole of any substance contains the Avogadro's number, which is 6.02 times 10 to the power of 23 of particles if you forgot. You can refer to a mole of atoms, molecules, ions, electrons, and so on. It can be applied to any entity. It is just a number. From this, we can easily calculate the number of particles in any portion or multiple of a mole of a substance. The Avogadro number is defined as the mass of one mole of substance and is exactly to the substance's relative atomic mass expressed in grams. This is known as the molar mass, and given the symbol capital M with the unit G/mol, which is derived as SI unit, using the examples discussed already, we can now deduce the following. From our knowledge of molar mass, we can state that the definition of the mole as the mass of a substance that contains as many particles as there are atoms of 12 grams of carbon in a carbon-12. Now we truly are able to use the concept of the mole to make it all-important link between the number of particles and the number of mass in grams. This is key to conversions in grams to moles and moles to grams. Now that we've learned molar mass, mole, Avogadro's number, and the key to balancing chemical equations, we will be now moving into real-life examples of this segment and also examples of how to solve stoichiometric problems. Back to you, Bobby.
Hello guys, Bobby's back. So we're going to be talking about some quick problems, really easy, just to compile all our knowledge into one question. So a tablespoon of water holds 0.5 moles of water. How many molecules are present? So we can see that we know that 1 mole of water contains 6.02 times 10 to the power 23 molecules of water. And therefore 0.5 moles of water has 0.5 divided by 1 moles multiplied by 6.02 times 10 to the power 23 molecules, which gives us 3.01 times 10 to the power 23 moles of water. Easy as pie, easy 2-3 marks on an IB exam. Now this question is a bit more challenging as it's asking for the amount of moles rather than the number of particles. So they give us the mass of the substance, which is 32.5 grams in 1A. So to do this, we need to calculate the molar mass of this whole compound. So we have to add each individual element's molar mass and put it in the denominator. So after we do that, you add 14.01 plus 1.1 times 4 times 2 plus 32.07 and so on, and you receive 132.7 grams per mole. After that, you divide the amount of substance given divided by the molar mass, which gives you 0.2459 moles. Similarly, for 1B, you perform the exact same thing. You add up all the the mass is given on the periodic table, which gives you the total molar mass for the substance, and you divide it by the mass given divided by the molar mass, which gives you 2.532 moles. So now we're going to be looking at airbag design as one of our real life examples. So the first thing, we need for an airbag, they need to find out how many grams of sodium nitride need to make in order for the bag to inflate. So in order to do this, they need to first create a chemical equation, then balance it, and then after creating those first two steps, those first two steps are absolutely imperative for everyone in order to create a stoichiometric problem. Then after that, then they find the amount of grams of nitrogen and then do a mole-to-mole ratio, and then they receive the amount of weight for iron oxide. And lastly, for the last real-life example, we're going to be looking at the compound diborane was at one time considered used for rocket fuel. So how many grams of liquid oxygen would a rocket have to carry to burn 10 kilograms of diborane completely? So using a chemical equation, they had to balance the chemical equation first by adding the 3 to the oxygen and 3 to the water, and then therefore they have to find the amount of grams of oxygen needed. So they have the 10 kilograms of diborane, convert that to moles, then do a mole-to-mole ratio, and then they receive the amount of grams needed of oxygen.
Thank you all for tuning into the Desi News Network today. I hope you've all clarified your understanding on stoichiometric concepts, stoichiometric relationship, balancing equations, molar mass, and I hope we provide you enough examples to really fortify your understanding today. And I hope you guys are tuned in next time for the next segment of the Desi News Network about limiting and excess regions. Thank you and sayonara.